I would like to welcome you to Webinar Wednesday edition 2, so the second Webinar Wednesday. Webinar Wednesday, what is it? It's a global webinar series to showcase latest natural refrigerant trends, products, and technologies. So it is part of our market development activities, of shecco's market development activities, to connect the right sources, to spread knowledge, and to drive the business case for natural refrigerants worldwide. So one sentence about us: we are a market accelerator, so we do very different things, including organizing events, publishing on online platforms to spread knowledge and present products, as well as launching online and print magazines. And last but not least, we also do research. We're active in market research and on market and technology trends, as well as policy trends. So today's topic is a guide to natural refrigerants in Japan, State of the Industry 2016. It's a special report we launched just a very short while ago, and we wanted to share the knowledge we gained from this publication review. So the session will take around 1 hour, including Q&A. Don't be shy, ask questions. I will explain to you in a minute how that works. For today's Webinar Wednesday, we timed it in a way that we wanted to reach the Asian, the Australians, the Europeans, the Africans. So whenever you want to share the webinar with your colleagues that might be sleeping right now, or if you yourself want to look at the slides again, you can do so by looking at our recording that will be done. It's being done right now, and that will be sent to you shortly after the session. So how can you access these recordings? Either you go to webinarwednesday.net, which is the official website for our series, or you follow our YouTube channel for Webinar Wednesday, which is the address you can see on this slide. There you can also find the previous recordings, for example, the one, if you missed the first edition in May, where Danfoss was talking about CO2 solutions, you can find these on these two channels. But the best part of a webinar, obviously, is always to be as interactive as possible, so you can interact live with us, with the speakers. How this works, I will explain to you now. So just a few housekeeping rules at the beginning. You can see the audio settings at the top right-hand corner of your screen. You should see them. So if you can't hear us or you can't see us, you need to please check the settings and see if your microphone works. By default, all of you are muted, so we can't see or hear what you are doing. And next to the audio settings, you have the Q&A button, and this is the major tool for you to use. If you have a question to us on a content side, so to our presentation, you want to ask something, please type in your question, and we will collect these questions and ask them at the right time. If you have a technical problem also, something doesn't work, then you can also use that Q&A function, and we will collect that and respond to you in writing. So the next one is, some of you might have also a chat function, and the chat function is disabled for all of you today because we didn't want to confuse you too much, also make it not too complicated. So please don't use the chat button. But what you could use is the raise hand function. This is if we say something and you agree with a statement, for example, or if you want to flag something, then you can raise your hand. That is something. So if you want to get in contact with us, please use the Q&A mostly. If you want to contact us for any question afterwards, you can always do so at webinar@shecco.com. Okay, so this is enough for the practical details. Let's get started. I'm very happy, I'm especially happy to be moderating this second webinar. I see that there are a few people raising their hands, so maybe Justina, you can find out if there's any technical problem. I continue in the meantime. So I'm especially happy to be moderating the second webinar, since I had the pleasure to be personally involved in the project, in the guide project, the Guide to Natural Refrigerants in Japan, State of the Industry. And I share this project with two of my esteemed colleagues, Jan and Clara. And so I believe that having them on board for today's webinars is the best choice we could have, because they are the real experts on the market and the policy side. Jan is our business development manager in Shecco, Japan, and so he's obviously the one that knows best about the Japanese market developments. And Clara is our deputy manager for market development, and she operates from the Brussels office for our European activities. In the background, we also have Justina, so we have 4 today from Shecco to take care of you, who will be responsible for all the technical details. So she receives your questions. Also, if you have some problems, she can interact with you. As I was saying, to make this as interactive as possible, after each presenter, we will allow for questions. So don't be shy, send us your questions right from the beginning if something is not clear to you, if you want to know more. So we will filter them and take them at the end of each speaker, and then we will have a general Q&A at the end. So, okay, I'm obviously not going to read out my bio, but just to say that I've been in this industry for 10 years now, having anniversary for Shecco in September for 10 years, and I'm still very motivated to work with natural refrigerants. It's a growing industry, it's an exciting industry. And so right now I'm responsible for all the market development activities Shecco has around the world. About the Guide Japan. So what is the Guide Japan? What are we going to talk about in the next hour? It is the first comprehensive guide or report on the natural refrigerants, on the market, technology, and policy trends in Japan. So what we did here is we present technology and market maps, try to put infographics there. We focus specifically on 4 sectors that show the highest dynamic developments, namely light commercial, commercial and industrial refrigeration, as well as heat pumps. We also did quite a few interviews of market leaders in Japan and outside Japan, the ones that have something to do with the Japanese market. And then we did industry surveys also among the market leaders. We provide a market outlook, and we provide as many examples as we could find for the individual use of natural refrigerants. This guide would have not been possible without the support of some market leaders, and they come from Japan and also outside Japan. They serve a variety of applications. And right after the webinar, if you're interested in having all the details, please go to publications.shecco.com, where you can find the Guide Japan. So why a Guide Japan? Why was it, from our point of view, why was it a good timing to do this now? Because one of the questions we asked in the industry survey was about what is driving your business for natural refrigerants? Why do you invest time and money in this? And obviously the environmental impact, the beneficial environmental impact of natural refrigerants, direct emissions, indirect emissions is the most important driver, followed by efficiency and performance and compliance with legislation. That means compliance with legislation that exists today and the one we can expect is coming up in the near future, as we see that things are moving at the international level, for example. And then there's another reason that is important for the industry that is active in Japan is financial incentives. They rank higher than in other regions, so it seems that the Japanese industry is making good use of these tools. And altogether, we can say there's a lot of importance on the policy side. That's why we dedicate a whole section today on the policy drivers as well. What we did is just an overview of the industry surveys, like the profile. So we asked, as I said, the market leaders and the industry, so mostly system manufacturers responded, followed by engineering contractors and component suppliers. We also had quite a few end users participating. And when it comes to the activity sectors, they come mostly from the commercial and industrial side. So transport, mobile applications or domestic residential applications are a little bit less represented. When we talk about dynamic markets, I want to put the Japanese developments into a global perspective, because more than for any other guides we did before, for example, the one on Europe or on North America or China, we tried for the Japan one to put that into a global perspective, to compare a little bit what is going on in Japan as compared to the rest of the world. So when we look at the general market trends worldwide, we see that for light commercial refrigeration, a few regions really are pushing ahead here. North America is quickly catching up here when it comes to the use of hydrocarbons and CO2. we have, and these are numbers from earlier this year, 300,000 HFC-free units. So there's a 17 times increase as compared to 3 years ago. And there's a very strong trend now from nearly non-existent to stronger use of hydrocarbons in the food service. So for example, fast food restaurants. When it comes to Europe, we have more than 2 million HFC-free units, also constantly growing this number, also including in ice cream freezers and bottle coolers. This is mostly related to hydrocarbon use in plug-in systems and also in food retail where it's coming more and more. And China, as a last interesting region before we come to Japan, is quickly catching up here also on the uptake of natural refrigerant-based equipment, not only like commercial refrigeration. An interesting development there is that the government will probably in September launch an official list of refrigerant alternatives, and there's plenty of natural refrigerants contained in there, so the country has ambitious targets. Now, this is to see what other regions were doing. Now, specifically for Japan, since we talk about the country today, we have 1.35 million beverage vending machines in the country using either hydrocarbons or CO2. That's 50% of the market share, so a very impressive number. And even more impressive is the increase from 0.1% to 52% in just 10 years. So it's one of those famous Japanese success stories, similar to heat pumps, for example, where just really in a few years, the market has picked up quite a lot. And the graphic you can see is the share of CO2 and hydrocarbons, but my colleague Jan is going to go into a little bit more detail also on the technology and the innovation side later on. So that is no real surprise that there's a big market, because Japan has the highest number of beverage vending machines per capita, and so this will have a significant impact on the overall market. Technology development has been steep there. Japan, there's a big but, however, Japan has not made similar progress in natural refrigerant use for small plug-in units. So as I was just showing you for North America, Europe, even China, a major trend is the use of hydrocarbons, and this is not yet so pronounced in Japan. When we come to commercial refrigeration, this is a map that some of you might have seen before as well. It is constantly monitoring on our side of the CO2 transcritical food retail stores in the world. So the stores that use CO2 transcritical units, and Europe, we are just collecting the numbers for Europe as we speak, and so this number will be updated in a few weeks from now in a new report we will launch by October. So the numbers you see here are a mixture of earlier this year, end of last year. The most recent ones are probably the ones for Australia and New Zealand. But the main message here on this one is that 3 hotspots have emerged: Europe, Asia, and here mostly Japan. Again, putting it into a global perspective, and North America is also coming. And the interesting fact here is with different technology focus, and that is one maybe of the most interesting sections in Jan's presentation, to see how the Japanese technology differs from the rest of the world and where the opportunities are. And then some outstanding countries like South Africa, Indonesia, as individual countries as compared to regions, they stand out as an example of the commitment from food retailers to go to CO2. So when we come to Japan, very briefly, an increase from 190 CO2 stores to 1,500. And again, this number has been updated in the meantime. So in just 2 years, and that's another major drive in Japan. So out of the small CVS stores that use CO2 transcritical systems, most are smaller stores. So most are CVS stores with a capacity of below 10 kilowatts. And then 4% of the stores from all Japanese 3 leading CVS brands right now use CO2 transcritical systems. So there's a lot of market potential still waiting. But again, there's a but here. Only 72 supermarkets have transcritical solutions installed. That is something that is very different, for example, from Europe, where supermarkets or bigger systems have a higher market share. And that the reason is here on the policy side, and Clara will explain a little bit more how the High Pressure Gas Safety Act has slowed down the uptake of such solutions. The new trend here is that Japan is exporting this technology to the region, including to Indonesia, Taiwan, Southeast Asia. and to Europe and North America. So this is a slide, I mean, while it's probably not representative because we have asked mostly we got responses from the ones being active in natural refrigerant technology, but it shows within the natural refrigerants that CO2 by far, like with a significant head start, has an advantage right now in Japan. It means that the expertise the Japanese industry built like from 15 years ago when they first launched CO2 heat pumps has been used and expanded to other application areas. The last sector I want to just highlight very briefly is for industrial refrigeration, where the market is changing. This is mostly coming from the international level, also the national level, to phase out R222 and find good solutions. And here the lower charge ammonia systems are one of the solutions that Japan has opted for. There are around 300 installations that use ammonia CO2 secondary systems. Again, the use of CO2 transcritical systems, as Jan will explain a little bit later, is slowed down by policy. And here also to say that exporting the technology to other regions is shown pretty well on this slide, where you see where Japan is exporting these ammonia CO2 industrial refrigeration units, so mostly to the Australasia region, but also more and more to Canada and the United States and Mexico. And this is my last slide, just for the general introduction. It is a slide where we ask people to indicate to which regions they generally, across all applications, across all natural refrigerants, export their technology. And you see that besides the Australasia, Southeast Asia region, Europe is quite a popular market for Japanese technology to be used, as well as North America. If you have any questions at this point, I'm very happy to take some before we jump right into the specific market trends and the application areas for natural refrigerants. Do we have any questions?
Yes, thank you very much, Nina, for your presentation. And we actually received already one question, and it's from anonymous viewer, and he is asking, do you include HFOs in the classification of HFCs for market statistics, or are HFOs categorized as natural?
No, HFOs are not categorized as natural refrigerants. Natural refrigerants are those substances that occur naturally in the environment, although they also have to be cleaned and manufactured, but they are less. They are to be distinguished from the synthetic refrigerants. So HFOs for us fall into the category of HFCs, which they are in fact.
Okay, thank you. Well, we haven't received any new questions, but I would just like to remind the audience that you could just click on Q&A button and type your question, and we will answer it live or in writing.
Okay, so the next speaker is my colleague Jan, and he's going to talk about Japan natural refrigerant markets and key applications. Jan, before we switch to you, just to introduce you, Jan is our engineer. He holds a doctor in engineering degree, so he knows. And if you have any technical questions, you can bombard him with that. He has a master's degree also from the Czech Technical University in Prague. And not to go into too much detail, but he has global experience, and he's currently based in Tokyo. As I said, he's our business development manager over there. So he's very strong connections to the Japanese, to the Asian, to the Australian industry, and is building the market for natural refrigerants in that region. Over to you, Jan.
Thank you very much. Thank you very much for your introduction, Nina. Welcome everyone again. We are very happy that you came to join us to listen more about what's happening in Japan. I will start right away. I will talk a little bit more about different applications that we covered, and also that were beyond the scope of the publication, where natural refrigerants are used currently in Japan. I hope everybody can see me and hear me well, so I will proceed. To start off, as you know, we have focused in the guide publication on 4 major sectors: commercial refrigeration, light commercial refrigeration, heat pumps, and industrial refrigeration. However, in these first few initial slides, I would like to point out that there is many more sectors and many more applications where natural refrigerants are already used. To start with food chain, we will talk in more details about food processing, about the cold stores, about the supermarkets and convenience stores, but I would like to also point out that in transport or domestic refrigeration, we have seen natural refrigerants ever since 2002. In 2002, Japan was actually the first country that used CO2 as a refrigerant for passenger car. It was the first Toyota fuel cell developed by cooperation of Japanese industry, Toyota, and Japanese suppliers. Domestic refrigerators, we know that annually there is 4 million of units shipped with hydrocarbon 600A refrigerant. So that's another success story of Japanese industry for converting from HFCs to natural refrigerants. Next slide, we will talk in more detail about vending machines, supermarkets, and convenience stores. So I will get to this later. City and buildings, and again, this is beyond the scope of the publication, but it's important to point out that we have seen a lot of absorption chillers used for air conditioning of big buildings ever since 70s or 80s. That's a big success story of natural refrigerants in Japan and in Asia in general. We have tens of thousands of these chillers already used for air conditioning. Also, we see a lot of commercial and industrial CO2 heat pumps being used in facilities as hotels and hospitals or spa. As you know, spa is a very popular destination in Japan. Next slide, city and buildings. Residential, we will talk about CO2 heat pumps. And I already mentioned the residential fridges, passenger cars. It's the first CO2 MAC application in the world, I believe. Special application worth mentioning is the sport facilities. In 1998, there was an Olympic in Nagano. Czech Republic, by the way, won gold medal in ice hockey. So I'm very likely to use this example in all my presentations. But a number of facilities such as ice skate rinks or curling facilities were using ammonia and CO2 ever since then. So there's a number of facilities with CO2 and ammonia refrigerants in use at the moment as well. I will start with the first chapter, light commercial refrigeration in Japan. This is really something that we mention a lot of times as a success story of Japanese industry, because basically vending machines in Japan, there is 2.5 million of them. They have already phased out HFCs. There is no new HFC machines being introduced at the market. So natural refrigerants are taking the lead. It's over 50% at the moment. Nina already mentioned the success story of vending machines. Just to be more specific, we have over 500,000 of hydrocarbon vending machines in the market and over 840,000 of CO2 vending machines. I will go into a little bit more detail when it comes to technology and some special applications. Coca-Cola Japan is really the driving end user behind this adoption of natural refrigerants. They have committed to have all their vending machines in Japan equipped with natural refrigerants by 2020, which is really driving the market. And I would like to mention this very specific Japanese technology called peak shift vending machine. At the moment, there is over 130,000 of them. This peak shift technology basically enables to cut the electricity consumption during the day for up to 16 hours without using any electricity whatsoever, and therefore cut the energy consumption by 95%. This is a very important topic because after the accident in Fukushima, there was issues with the availability of electricity. So this technology helps mitigate this very serious problem. So the Coca-Cola continues to introduce the peak shift vending machine as one of their flagship models. Another example is, I believe Japan is the only country where CO2 ejectors are used in vending machines. This is a technology that was developed by Denso originally for the EcoQute heat pumps. It has been deployed in the first models of the CO2 vending machines in 2015. So there is now first pilot projects being tested in the field, and the results, as were presented at the Atmosphere Asia in February, are pointing to up to 25% energy reduction. So we really see that ejector can play a very important role also in the vending machine and light commercial sector. We have conducted survey about light commercial equipment in Japan, and in this sector, and vending machines, water coolers, freezers, 74% of the respondents were sure that the market will grow in future. The market for natural refrigerants will increase by 2020. We believe that's a very strong signal. Naturally, vending machines will be a strong driver for CO2 and hydrocarbons as well. We will see more hydrocarbons in the light commercial equipment that is being introduced by the global consumer brands like Red Bull and Unilever. We see that there is a huge potential for this small equipment for both CO2 and HC. So at the moment, still, if you attend the trade shows like Hoteres, most of the light commercial equipment is on 134A. So there is a huge potential to move in the direction of natural refrigerants, as we see in Europe and US nowadays. Moving to commercial refrigeration, that's really where there is the most development over the last couple years. We are very excited to see Japan taking the lead when it comes to a small footprint CO2 stores, natural refrigerants. So the 1,500 plus stores, transcritical stores in Japan, this is data that we have accumulated till end of March 2016. Nowadays, we can say confidently that this number is closer to 17 or 1,800. We believe by the end of the year, it will be very close to 2,000. So this number, if you break it down, mostly it's convenience stores represented by leading brands as Lawson, 7-Eleven, Family Mart, Ministop. Those are really the brands that are driving the transition from HFCs to natural refrigerants. Lawson, at the moment, they are very close to 1,500 CO2 stores. Basically, all of their new stores are equipped with CO2 technology, except for special applications like in-building, etc. So convenience stores in Japan, I believe, are a very strong driver. Next slide, to introduce some of the leading supermarkets. Very different situation is in supermarket sector when the lack of availability of the largest system is a bit of a handicap. However, we see supermarket groups like Ion or Coop taking the lead with over 10 systems already installed, 10 supermarkets already equipped with CO2 refrigeration systems. So there's still a lot of barrier that Clara will also be talking about in her policy and regulatory overview. To talk a little bit more about the technology. So the difference between the US, Europe, and Japan is clearly that the typical rack systems available in West is not very used. There's only a few examples of the technology being used, but mostly, I would say close to 99% of all the refrigeration units are so-called condensing units using CO2 refrigerant. We have two major suppliers in Japan. The lineup of these condensing units is from 2 to 20 horsepower, roughly 1.5 to 15 kilowatts. The CO2 refrigeration units were already developed since 2008 when we have first installation. So we are at the second generation of the systems. These are already optimized or improved. There is a lower pressure going to the showcases, increased efficiency, etc. So there's a lot of the Japanese manufacturers have gone a long way on the learning curve, and the technology is progressing very strong beyond Japan as well. So we see different style of the condensing unit, cascade, refrigeration, CO2 transcritical, as well as the pressure control type. At the moment, there is a lot of discussion about ejectors in Europe and in US. In Japan, we are not aware of ejectors being used in commercial refrigeration beyond the vending machine example. But we see that it might be one of the incoming technologies over the next couple of years. There is also no integral systems at the moment. So typical convenience store installation, and you see one or two of these CO2 refrigeration units is installed in the back of the convenience store. In Japan, there is always a bit of a struggle regarding the space available. So compact condensing units are the way to go so far. A typical supermarket installation, however, in order to cover the needed cooling capacity, you would need a number of the condensing units, 20 horsepower units lined up. So we see some of the big supermarkets would be using up to 20, 30 of these units connected to the showcases inside of the store. So again, very typical installation for Japan, very different to what we see in Europe and US for a number of reasons, including the ones with cultures or the temperature setting of the showcases, etc. Different culture of the supermarkets. This is definitely an interesting example to mention that we have many condensing units in Japan. However, we also have the first booster system ever since last year. So the first booster system was installed in a supermarket as a part of the Ion group. It is 42 horsepower unit, 4 compressors. It's a typical rack that we are familiar with in Europe and US. Cooling capacity 33 kilowatts, refrigeration 7.5 kilowatt on freezer side, and it's a mid-sized supermarket with 12 showcases. So this is really the first example of the CO2 booster system used in Japan. We will see that there will be more of these coming up. Excuse me. And we will see that the system will be scaling up for larger supermarkets eventually. Another example of natural refrigerants technology is being used in supermarkets and convenience stores nowadays, the plugins. So a number of Japanese companies are offering a CO2 plug-in systems. We also know that there's 2 European suppliers providing the hydrocarbon plug-in systems in Japan with over 200 units nowadays installed by Japanese supermarkets and convenience stores. There is a lot of hydrocarbon plugins in Europe and in US. We know in Japan it's only the beginning of the trend. We believe it may take some more time, but there is a lot of change in the industry when it comes to understanding these technologies as well. Important to mention is that the current subsidy that is driving the market, that Clara will be introducing in more detail, is available for both for CO2 and hydrocarbon plugins. And when it comes to new technology, the trends that we are expecting, that we are seeing coming to market, the CO2 condensing units, it has already been announced that the larger unit will be piloted, tested this year, up to 30 horsepower unit by Panasonic. We also see the first booster system in convenience store, larger systems being now piloted in industrial sector, so that will be coming to commercial as well. The next challenge is we believe there is a space for ammonia CO2 systems in large supermarkets, ejectors, as we've seen in Europe and US and elsewhere, integral systems that would really come with the big racks to take advantage of the properties of CO2 and then the heat reclaim, etc. And finally, the big CO2 racks that are available in Australia, Europe, or America. So by 2020, the respondents believe that, and 79% of the respondents believe that the natural refrigerants will increase in commercial refrigeration, which is a very positive sign. Moving to industrial refrigeration. So Japan has been a leader, one of the leaders in introducing the next generation ammonia CO2 systems to industrial refrigeration. In particular, ammonia CO2 secondary system is rather popular in Japan. There is 2 major manufacturers provided this prefabricated system with reduced charge of ammonia. The package systems are in the capacity between 100 and 300 kilowatts. As you see on the picture, let me highlight, as you see on the picture, a number of these units would be connected to cover the cooling capacity needed for a cold store or food manufacturing. So at the moment, there is over 300 projects in industrial refrigeration covering mostly cold stores, food processing, and special applications, export facilities. and over 1,000 units already used in the market. So that's a trend that we believe will be continue. We also see a number of air refrigerant cycles being used in the low temperature applications, like tuna freezing facilities and similar. Again, MOE subsidy is one of the main drivers behind the introduction of a number of these systems in recent years. New technology trends. What we believe is the first CO2 booster system was installed in a tunnel freezer for food processing. So that's again a sign of a change in Japanese market that has traditionally been using the ammonia CO2 last several years. So there is the first CO2 booster system. There is a number of projects being now discussed about with using ammonia and CO2 cascade refrigeration, which is also a big difference. And this is these systems are a collaboration of industrial, international and domestic suppliers. A number of projects are planned for 2016. So we see the market in both commercial and industrial refrigeration are becoming more competitive. And some of the next challenges, integral systems, ejectors, larger systems, similar to what we see in commercial refrigeration. With availability of the large CO2 systems, there is also new opportunities to use ejectors, to use heat reclaim, to really optimize the energy efficiency and savings with the large systems. That's all the opportunities ahead. And a little bit more about heat pumps. I'm sure you all are familiar with probably one of the single biggest success of Japanese industry, called EcoCute. EcoCute stands for the CO2 heat pump water heater. We know that at the moment there is over 5 million units in the market, which is a very impressive number, unheard of anywhere else in the world at the moment. Annually there is over 400,000 units installed. So that's ongoing success. The CO2 heat pump really has changed the market. It's become a standard technology. And 98% of all residential heat pump water heaters are using CO2 refrigerant. So this is something that the Japanese technology can really contribute to changing the market dramatically, and has a potential to be introduced elsewhere in the world, as we see nowadays in Europe and US. Technology trends. The first CO2 EcoCute heat pump was introduced in 2001, so it's a long time ago, over 15 years. And during that time, a lot of technology improvement on the CO2 refrigeration cycle already happened. So the latest technology trends or changes are really more connected with the periphery of the system, with the hot water tank, with the remote control, with connectivity, with the design and high pressure water delivery, shape of the system. So again, it can accommodate the location in the very limited space, etc. So there is a lot of the major challenge that we have been hearing about from the suppliers that we work with is really the cost. Cost is the last hurdle. The efficiency is there. The CO2 is probably the most suitable refrigerant for this application. So there is very limited competition when it comes to the solution itself, but cost is one of the next challenges that are ahead again. So to mention some of the new technology trends, the domination of CO2 heat pump for the last 15 years is very clear. However, what we see ever since 2013, there is a competing solution also using natural refrigerants. A Japanese manufacturer has introduced a hybrid heat pump using hydrocarbon compressor, hydrocarbon heat pump, and a gas burner to provide hot water. So we know that there is already 2,000 units in the market. My apologies. There's already 2,000 units in the market, and the demand is increasing. So this is what we like to see, that there is more and more competition between natural refrigerants, and we basically see a very limited introduction of new HFCs in the sector. So R32 was introduced several years ago, however, but to very limited success. So CO2 has a clear position in the market that is unshakable at the moment. And that will be all. I'm available for any question from any of you.
Thank you very much, Jan, for such an interesting presentation. And we received some questions for you. Well, the first question comes from Anil Kumar Yadav. And he is asking whether Indonesia market uses only for food retail applications or for GDM as well. Well, I am not very sure what GDM means. Maybe Anil Kumar could be able to raise his hand and clarify this question live. In the meantime, we can also ask other questions, and I'll wait for the response from Anil Kumar to clarify the question. Okay, so Israel Kazanov is asking, can you please share information about blast freezing natural refrigerant-based technologies development in Japan, if possible, information about major players, manufacturers?
In which sector was it, just to make sure?
It's freezing natural refrigerant-based technologies, if I understand correctly.
Blast freezing, Jan, blast freezing technologies.
Blast freezing. Okay. Well, this is industrial refrigeration sector. We know that there is two major players in the market. Maikawa is the player with the biggest market share. Mitsubishi Heavy Industries that acquired Toyo Electrical Works are the second competitor. We now see other companies entering the market that are based on the technologies coming from Europe or elsewhere in the world. Blast freezing, I believe these two companies are the strongest players in the market, so they will be equipped to serve blast freezing as well. There's a lot of tunnel freezing project, food manufacturing, processing, cold stores. So I don't know specifics about the latest blast freezing project, but I believe these two companies would be involved.
Okay, thank you, Jan. Another question comes from Baggio Lamana, asking which are the charge limits per circuit for hydrocarbons in Japan for commercial refrigeration?
So at the moment, there is a lack of regulation for hydrocarbons. So 150 grams is universally applied to commercial refrigeration technologies as well. None of the hydrocarbon technologies are actually manufactured in Japan. So these the plug-in systems that are now used are being imported to Japan. The standard when it comes to handling the hydrocarbons is taken actually from the residential refrigerator. So lack of the standards regulation regarding hydrocarbons is one of the barriers.
Okay, thank you. Interpol Sound is asking, is there any commitment from end users in Japan for CO2 booster systems for supermarkets and hypermarkets?
There is definitely interest. What we see, it's a bit of a chicken and egg problem. So the end users are asking for more CO2 technologies and lower price. The suppliers are asking for demand. So at the moment, it's there is one CO2 booster system installed in the supermarket. There is a number of planned projects for CO2 booster systems, but we don't see this to be changed very quickly over the next 1 or 2 years with large supermarkets as we've seen in Australia. So there is definitely a demand from the major supermarket manufacturers. Supermarket operators and users.
Okay, and we actually received a clarification from Anil Kumar Yadav. He's saying that GDM is glass odd merchandiser. So if I read the whole question, then the question was if Indonesia market uses only for food retail applications or for glass door merchandisers.
So what we know about Indonesia, Lawson has been working with its partner Alphamidi, and there is also a case study in Gai, Japan, on introducing the CO2 technologies, working with Panasonic in Jakarta, a number of locations. There's 13 stores equipped with CO2. So these would be the remote condensing units using CO2 showcases as well as plugins. I don't think this is limited to, or this is also including the small bottle coolers, if that's what you mean. And another project we know in Indonesia is also on the industrial side, using the ammonia CO2 technology.
Okay, thank you. Shall I take another question if we have time? Francesco Cataneo is asking, what is the potential for hydrocarbons in Japan for industrial refrigeration and general process cooling?
Wow, that's a difficult question. It's hard to say. Hydrocarbons, as you know, it's a difficult market for Japan. I believe they will be more successful in the very small applications when we see hundreds of thousands of examples of units being installed in Europe and US already. So I think hydrocarbons will enter into Japanese market through the small equipment, very small capacity bottle coolers and freezers. The industrial, there is one or two examples that we have also mentioned in the guide where hydrocarbons are used in process cooling, but I would not say that there is a big potential in comparison with CO2 and ammonia for a number of reasons, including the cultural one.
Okay, thanks, Jan. And I think we should move already to the next speaker.
I think so, yes. Okay, so next up is Clara, my colleague Clara, and she's going to talk about policy, which we mentioned quite a few times already, having a big impact on the market. Just a few words about Clara. Just a few words about Clara. So Clara holds a master's degree in international relations, so she really is an expert on the policy side. And I have been working with her for several years now, together on the market development team. She's based in the Brussels office, and she really has a very good global overview of policy making and market trends when it comes to the US, to Europe, to Asia, including Australia. So she's an expert on this. So over to you, Clara.
Thank you very much, Nina, and thank you everyone for joining us. So I would like to give you a short snapshot about the policy trends for natural refrigerants in Japan. So first off, I would like to start with a survey results that Nina already alluded to in her introduction. We asked the representatives of the industry to identify the key drivers for natural refrigerants in Japan. And on top of this list, environmental impact as well as energy efficiency and performance were ranked, which indirectly relate to policy measures. But the industry also considers the compliance with the current and future legislation as important factors. Besides that, the financial support that is provided by the government plays an important role, and it has been ranked higher than in other regions where we asked a similar question. So this indicates that financial incentives do have a very important role to play in the Japanese market. Now, looking more closely at the policy drivers for natural refrigerants, again, in the survey we asked which of the policy drivers are the most important for introduction of natural refrigerants. And here it was confirmed again that the government financial subsidies for end users as well as manufacturers are considered to be the most significant driver currently. Besides that, potential global agreement on a HFC phase down, which is currently being discussed on an international level, could be an important driver once this is agreed. On the other side, energy efficiency targets and training and certification for natural refrigerants are not seen as a major driver compared to the other measures and initiatives in Japan. Japan has recently revised its F-gas law, and it came into effect in April 2015. so more than 1 year ago. It targets the entire life cycle of F-gases, from production through use of equipment to destruction, and it introduces several new measures and strengthens the measures that were already in place before. It strengthens the containment measures, especially for commercial refrigeration, including periodical checks, maintenance, and reporting. And it also promotes low GWP or non-F-gas alternatives in certain sectors, which are so-called designated products. Now, zooming in a little bit more on these designated products, applications in 5 sectors were identified, including room air conditioning, commercial air conditioning, condensing units and refrigeration, cold store warehouses, and mobile air conditioning. So for these 5 categories, the government has set target values in terms of GWP that the manufacturers need to reach by a certain target year. So for room air conditioning, the targets were set at 750. But what's interesting also from the perspective that Jan had already presented, in commercial refrigeration, for condensing units and refrigeration units, the targets are not as ambitious as they could be given the availability of the CO2 in the market. And when we also compare it to other regions such as EU, Japan is a little bit lagging behind in this respect. So the targets for designated products have been set for the sectors with the highest environmental impact. So this is how the list was established. And also the sectors already have low GWP or non-fluorinated replacements that exist. The compliance is measured as a weighted average GWP for the entire production and import. And the Ministry of Environment and the Ministry of Industry have done some preliminary calculations to evaluate the effects of the HFC emissions reduction of different measures. And the table here shows that the promotion of low GWP alternatives in the designated products can deliver the highest emissions reductions compared to other measures such as containment from commercial refrigeration. Based on this calculation, by 2030, the reduction could be 5 to 8 times higher for promotion of low GWP alternatives. So besides the F-gas law, there are also incentives in place by the Ministry of Environment to motivate the end users to move away from HFCs and HCFCs in different applications. And a subsidy scheme that was introduced initially for a period of 3 years in 2014 has been growing not only in scope, but also in the budget. So it started off in 2014 with a budget of 5 million Japanese yen, and it supported end users in adoption of natural refrigerants in food retail and cold storage warehouses. Then in 2015, it broadened the scope to include food manufacturing. And this year, 2 more sectors are eligible to receive the funding, including chemical manufacturing and ice skate rinks. There is currently a lot of discussion about what's going to happen after 2016. And the Ministry of Environment is in discussion with the Ministry of Finance about the continuation of the subsidy scheme. Especially the end users have been asking for the subsidy scheme to continue, so they're able to continue in the adoption of natural refrigerants at a similar rate as they have in the last few years. So besides the subsidy scheme on the national level, the Tokyo metropolitan government also promotes the use of natural refrigerants regionally, and this subsidy scheme is smaller in budget. But it targets especially small and medium-sized businesses in promoting energy efficient showcases that use natural refrigerants. So as it was already mentioned by my colleagues, there are not only drivers, but there are also barriers in legislation. One such example is the High Pressure Gas Safety Act, which is a barrier for CO2, especially in larger equipment, for supermarkets, CO2 booster system, or for industrial refrigeration. Basically, the High Pressure Gas Safety Act sets a limit for equipment using CO2 above 40 to 50 horsepower, whereby the equipment that is above this limit is required to provide additional administrative permissions, as well as regular checks, and this adds significant administrative barrier, especially to retailers, which makes it prohibitively expensive for the companies to introduce the technology. There are several players in the market that are asking to revise this act to allow for wider application of CO2 in larger equipment. Currently, there is no such revision in view in the near term, but this could, of course, change very quickly. In order to incentivize the energy efficiency, the government has introduced in 1999 the Top Runner program for energy intensive products. Currently, it applies for 21 product categories, including CO2 heat pumps. The aim is to encourage the companies to move towards the most energy efficient models by a certain target year. If these targets are not met, then the government can issue some recommendations, or they can publish names of companies that do not meet these targets. But as far as we know, that this has not happened yet. And now looking a little bit more into international policy and how Japan is involved in this. So Japan is, of course, committed to phasing out HCFCs under the Montreal Protocol, and they have committed to phase out these substances by 2020. They, of course, have some challenges in certain sectors, such as industrial refrigeration, where majorities of the equipment still uses R22. But Japan is also supporting the global HFC phase down, which is currently being discussed internationally to be included under the Montreal Protocol. So just last week, I attended a meeting in Vienna where they were discussing about the next steps and how this global HFC phase down could look like. They made a significant progress in the negotiations. There is still a lot of work to be done, but there are hopes that are quite high that an amendment could be agreed by end of this year. More specifically in October in Rwanda. So there's something to look out for. This could create opportunities for Japan, of course, especially for the companies that already manufacture equipment using natural refrigerants. But Japan could face also challenges because they would have to speed up on their policy side domestically in order to remain competitive. Japan already supports projects in developing countries through joint crediting mechanism. One such example is the introduction of CO2 transcritical technology in Indonesia. So that concludes the policy part, and just some of the concluding remarks on behalf also of my colleagues. We can see some key trends in the market. One of the clear trends is the introduction of CO2 in light commercial and commercial refrigeration, as well as heat pumps, ammonia, CO2 industrial refrigeration, which is expected to continue. When talking about the potential for the near term, we can expect to see hydrocarbons in light commercial refrigeration, as well as CO2 in industrial refrigeration and in larger supermarkets. Talking about the medium to long-term potential, there are expectations that the industry will move towards next generation natural refrigerant systems. using integrated technology in convenience stores and supermarkets. And there is also potential for CO2 in mobile air conditioning. Another clear trend is that the Japan's technology that has been tested and commercialized nationally is now increasingly reaching export markets where this technology is becoming more competitive. This is especially the case for ammonia CO2 industrial refrigeration, CO2 for convenience stores, heat pumps, and light commercial refrigeration. So you can find more information in the guides that we have published. Besides the Guide Japan that we published this year, last year we published Guide North America and Guide China, which gives a perspective on the use of natural refrigerants in these regions and countries. And the year before, we published a guide focusing on Europe. Besides the guides, there are also a number of different regional magazines available for Japan, America, Europe, Australia, and New Zealand, as well as the Natural Voice magazine, which targets more the developing countries' developments. More information you can find on the websites. So you can find here also the guides and the Accelerate magazines, as well as industry platforms. And now I open up the floor for questions, if there are any.
Okay, thank you very much, Clara. We have 2 remaining questions that we received from the audience, and I think the first one maybe goes for Nina. So Anil Kumar Yadav is asking, how do we see CO2 heat pumps in France market?
Okay, thanks, Anil, for that question. Well, it's a little bit outside Japan, of course, but since we're based in Europe, maybe it's easier for us to answer that one. Well, we know that CO2 heat pumps have been introduced to the European market, generally speaking, and they're certainly a very valid technical solution. After they were developed in Japan 15 years ago, they were then introduced to the European market. However, what we see is that the market is a little bit slower. I mean, a little bit significantly slower in terms of uptake. There have been very valuable trial solutions been made, and the solutions have been introduced to the market. And we know that there are quite a few players on the European market to offer CO2 heat pumps. But in terms of market share, it's not as big. Obviously, it's far away from Japan or the introduction there. So when it comes specifically to France, we know that Sanden, which is a Japanese player, has developed, for example, a solution that's just one of the solutions, but since they are based in France, they developed a solution for the European market and adapted to the European conditions, because the conditions in Japan, as Jan was saying, the usage patterns, temperature, ambient temperatures, and the technology is a bit different from Europe. So the technology was adapted to European conditions and is now being marketed. But there are other Japanese players that are active on the European market, obviously, with CO2 solutions, for example, component suppliers, for example, as well, and several German, Northern European market players that have introduced these solutions.
Thank you very much, Nina. And I have a question for Jan now. Anshu Kumar is asking, how about CO2 visible coolers technology in high temperature, like India, with 50 degrees Celsius, for example? Any issues?
Any issues? I think it's. I would only refer to a number of presentations we have from end users like Coke or suppliers for both CO2 and hydrocarbons that basically are saying that they have technologies available for any part of the world. The CO2 and hydrocarbon technologies have, over the last 10 years, improved so much that there is very little barrier in deploying these technologies anywhere in the world. That's the message that we are receiving at the Atmosphere conferences and in our interviews for Accelerate. So I would say we have entered the time when we can apply these technologies anywhere in the world.
Thank you, Jan. And that's all questions that we received from the audience right now. If you have any last question, just type us. Okay, there is another question from Anshu Kumar. Hydrocarbons is comfortable, but what about CO2? So I think it's for you, Jan, as well.
Well, again, I can only refer to companies like Coca-Cola that has clearly said that they believe they have solutions for any part of the world as the CO2 has developed. We are not the technology experts, so we can refer to companies that are working with these technologies already. And they are saying we have models that are suitable for very hot ambient temperature parts of the world.
Okay, thank you. And an anonymous viewer is asking, what about usage of ammonia-based technologies in industrial refrigeration? So this is for you, Jan, I think.
So again, when I'm looking at Japan, we have ammonia has been used traditionally until 70s. I mean, ammonia, not low charge ammonia, but traditional pumped ammonia with thousands of kilograms of ammonia in the system. Then there was an accident in the 70s, which led government to basically substitute the transition towards HCFCs. That's a current problem. That's a current standard. R22 is still very much available in the market. So the latest trend is to phase out R22 HCFCs in all these remaining facilities. And there is over 10,000 of them in Japan still. To introduce ammonia CO2 systems, both secondary cascade and the CO2 refrigeration system. So ammonia is a standard technology in Japan for industrial sector, and it will continue to be so. I believe we also will see ammonia in more commercial, in large supermarkets eventually in the horizon 5 years, within 5 years.
Okay, thank you. And I think there is a comment from an anonymous viewer. He's referring to Anshu Kumar and saying that CO2 visible coolers are being used in India, but in small numbers today.
I would maybe just comment, please get in touch. We'll be very happy to hear about this. And then we can also provide this reply to Anshu Kumar, who we know very well.
Okay, that's all questions that we received. If any last question, just type it and we will answer live.
Okay, so the rest seems to be very clear. If you have questions, as I was saying earlier, you can contact us at webinar@shecco.com always. Also, please don't forget to visit our website. You can send us suggestions for future webinars. So if you're interested to organize one yourself, then you can also contact us at this email address. The recording will be done and will be made available in the next few days, and then will be available also on the YouTube channel, where I included the address a little bit earlier in the presentation. So any questions, contact us, and then we are ready